Today we will discuss about the system design phase. So this particular phase exactly addresses how we going to solve the problem. That means main objective of it is to formulate alternatives. What about how the problem should be solved? That means here you are going to look for alternative solutions and how these solutions can be solved. Okay, this is what is carried out during a system design part. So what is the input to this particular phase? So usually a software requirement specification document. As I said you before, so after requirement analysis, you have this phase. Okay, so unless the SRS is completed and it is reviewed by the customer as well as management and sign off users signed off for the project or the management signed off for the project, after which only we can go into system design phase. That is the reason why. So here the output of requirement analysis phase is an input to the design phase. So and now also because as I said you, so here we need to see several technical alternatives because it is all because it is a how part, right? So how are you going to solve that particular problem? So we will be using some technical alternatives, right? So whatever the technical alternatives available, so we are trying to use those technical alternatives. Let's say you can think of whether I need to go with a what sort of technology. Okay, I need to go with, let's say you can think of something like this, whether it's in a you going to develop the software using a Java technology or you wanted to develop the software using C++. Okay, so now you can think of, like, based upon certain technologies, you will decide what is the alternative and whether that alternative is feasible through this technology or not. Okay, and you try to identify the automation boundaries also, right? Usually, it is a separation between so your automated parts as well as the parts which can be done through a manual way, right? So that means it draws a outline, right? So your technical alternative should identify, okay, based upon this automation boundaries. Type of solution, whether it is a batch system or online system. Okay, so you know that what is a batch system? Batch system where you have certain number of tasks and these tasks are submitted to the system. At later point of time, these tasks will be, or the jobs will be processed by the system. Okay, whereas in case of online system, so the whatever the task has been assigned, whatever the task needs to be processed, so that will be done on it's on live. Okay, so something like you can think of, let's say you take an example of Amazon. So if you're going through an Amazon, so every statements, right, whatever the request that you are sending, so you will be getting that your request will be processed quickly as well as, and you going to see some sort of response quickly, right? So it's everything live. Okay, so there is a client and server, those sort of systems, right? So that means your technical alternatives should be decided based on whether it is a batch system you are going to develop or it's an online system. So and also whether you going to make or you going to buy certain things, right? So these sort of based upon those things also you need to check an alternative, right? So in the part of previous phase, so what you see, what we have seen, we have seen business alternatives, I mean the requirement alternatives, right? So now here from the business point of view, right, I mean here you see the technical alternatives actually. Okay, so because you are going to design here, you are because it is a how part, how you going to develop this particular system, right? So the proposed range of alternatives, so maybe the low cost, medium cost, comprehensive, high cost solutions, or whatever the kind of solution that you have, you need to propose all here during this system design part. Okay. Now the alternatives, for each alternatives, prepare high level design, high level system design. So whatever the alternatives we have seen, for all of these alternatives, now you need to prepare the high level system design. So the high level system design means here in terms of architecture or maybe a database device design, because it is a how part. Okay. So we are going to design something, right? How are you going to develop a database for your application? Okay. For that particular reason, so everything, so here you need to have a high level system design, right? So in terms of maybe architectures or database design, okay, as well as it should prepare implementation schedule. That means you should, I mean, how much time you would really require to finish this particular activity. So this sort of based upon that time also you need to decide the alternative. Carry out cost based cost benefit analysis, as well as you need to go through the cost benefit analysis, right? Based upon the time, how much how long you going to take, okay, and what would be the cost, okay, and based upon those things you need to identify that which alternative will be the preferred one. These sort of things will be carried out. So that is what exactly we say here. So prepare for technical and management reviews, right? So during part of any design phase, so whatever the alternatives we have chosen, so I mean you should be ready for technical as well as management reviews. So part of technical review, so you can see something whether the technological alternatives we have chosen, whether they are meaningful or not, okay, whether they are worthy or not, okay. And similarly, so in part of management review, so usually it should ensure that we are within the proposed cost, whether the whether we are developing, we are considering the alternative, whatever the alternative we are choosing, so whether that is falling within the proposed cost or not, okay, whether able to meet the schedule or not. But I mean, if you're going with this particular technology, so whether we'll be able
Yes, sir.
to develop the software or not. Yes, ask me.
So, what is, I didn't understand cost benefit analysis. Like, is it in terms of man hours or the money part of it, or and how does it one do the cost benefit analysis? What are the, like, will we continue it in later sessions or?
Yes, listen, yeah. So, right. So there is a project management topic, right? Maybe after, this process model, we will talk about how you gonna calculate this cost, so we will talk about them, because there are something like, cost, effort and all those things, right? But you need to, now you need to understand, whenever I say it's a cost, usually the cost in terms of tangible and intangible benefits. We have talked about this in the last lecture, right? So whether we are getting some benefits or not, right? As well as the investment that we are making, right? I mean, cost benefit we are talking about, right? We invest some money into this project, right? And whether we getting some tangible, intangible benefits, okay, whether we are getting some benefits or not from the system, right? So that is what exactly a cost benefit analysis. So here the cost is mostly, it's a money only, the money that we are investing into this particular project, right? So now this cost can be calculated based upon many factors, okay. So it is not only, I said you before also, so if there is a person who is going to work for 4 months, right, and that particular person is paid 1 lakh rupees, so then 4 months, so if 4 months, you need to pay 4 lakhs rupees to each and every individual person. So usually, that is one cost. Okay. Apart from that, you might have many other costs. In the last lecture, we have already discussed about them, right? Maybe you have a secretarial cost. You have a managerial cost, you have a rental cost, you have electricity cost, right? So because you found a space to work in, right? So I mean you have let's say you have an overhead, okay? So whatever the overhead charges for each and every organization, right? So all together that will be a cost, right? But ultimately we are investing some money, right? And so during this cost benefit analysis, what we are trying to do here is we try to see whether we are getting some benefits or not from the investments. Okay, if you're not getting benefits, then I think that's not, maybe the software that will be failed tomorrow. Okay, because people are not going to use that. Okay, am I addressed your question?
Yes, sir. Yes, sir.
Okay. So now what the part of design what we do here is we have taken certain technical alternatives, right? Now whether these technical alternatives, okay, they are meaningful or not, okay, whether they are worthwhile or not, whether these whether these technological alternatives we have chosen, whether they can be carried out within the proposed cost or not, whether they're going to meet the schedule or not. I mean schedule means, let's say we wanted to develop that particular project within 6 months, whether we will be able to develop the software within 6 months or not. So everything should be taken into consideration, and based upon that we need to choose the alternative. So those things should be mentioned here. Okay, so part of system design, let's say we have three alternatives, so we will be talking about all three alternatives. Okay, and then later on we will talk about that, right? So cost rise sharply hereafter. That means the cost of usually the cost of these projects rises sharply from this particular phase only. Okay, so cost can be quantified better at this stage. Okay, so that means you should be able to quantify the cost here in a better way, because hereafter you will be exactly going through an implementation phase. Okay, so technical review uncovers errors, checks consistency, completeness, alternatives also. Okay, so when you're going through these all technical reviews also, that means whether these technological alternatives they are very meaningful or not. So usually when going through these things, we try to detect some sort of errors also, right? And I mean whether if at all any requirement errors are there. Okay, so that can be detected here itself. Okay, so that means we are going through some sort of trying to find out the design errors here itself when you are going through, when you are reviewing these technical alternatives, right? So yeah, as well as we try to see whether we maintain consistency, completeness as per the SRS or not. Okay, so everything will be checked out here. Okay, and phase ends with a clear choice which can be further taken into design and implementation phase. Okay, so now exactly, so by the end of this particular phase, because there should be a clear recommendation. Okay, or the choice that should come, that we need to go with this alternative because this is the alternative. So it is falling within the proposed cost. Maybe it takes less amount of time, as well as maybe this is worthwhile, this particular technology, and it is very meaningful for the project, right? So based upon these all things, so we need to come with a clear conclusion that so this alternative should be we should continue with this particular alternative, right? Because the hereafter you are going into an implementation phase, right? So mainly the design goals here is, so what is the processing component? Okay, so I mean how this processing component can be taken. Okay, so how this processing component can be considered, because ultimately when you are talking about design, so ultimately we are talking about how we going to develop. Let's say we talked about a requirement, so we have identified a requirement and there is a function, right? So that function need to be developed here. Okay, during part of design we need to discuss about that particular processing, right? Let's say you can think of as I told you before, right? So when you give some input to a particular function, it should give some output. That is some function, and maybe it is a one requirement. Okay, so I can say you in case of ATM machine. Okay, in case of ATM machine, so one requirement is validating a user, right? I mean, so when you insert your card, and then when you insert your PIN code, okay, so it will check that whether you are a valid user or not. Okay, so what is the input here? Input here is your PIN code. Okay, and what is the what is the output? Output is something, maybe it will be allowing you to access certain other functions or the features inside the system, right? So now, so there is a processing required. Okay, so given this input, and that input will be checked whether this pin is a valid pin or not. This pin is a valid pin against this particular debit card or not. Okay, so that is what exactly checked. So there is a need of a processing, right? So when you going through this design, so we are talking about how part, how we going to design. Okay, I mean, how part it is, right? How we going to solve that particular problem, right? So this is the way that you need to understand, right? So now we have seen all alternatives, right? We need to see all alternatives. I mean, how this processing component can be developed. Okay. So let's say, for example, if you're going through any functional approach, that means the conventional method where, you know, it's a function oriented, because I mean, the software is developed using, you know, function oriented programs. Okay, so where you let's say, for example, you see about any C programming. Okay, where you do have a functions. Okay, where you do have a functions, and these functions take some input and gives you some it returns you some result. Okay, this is the sort of approach that we see in any conventional programming languages, right? So, and there is object oriented model also, where, you know, data as well as procedures or the functions, they are inside a single object. Okay, they are inside a single object, methods as well as your data, right? So now these approaches are very two different approaches, right? So you have a functional approach, there is object oriented approach. Now the processing alternatives that you are component that you are choosing, that is based upon the kind of implementation that you want, whether you will be going through a object oriented or you going through a functional oriented, right? So now, different design methodologies for functional as well as object oriented. So we have different design methodology for functional as well as object oriented. Okay. Now, as I said, you data component, that means so there is a previous one, there is a processing component, that means the function part. Okay, so how you gonna process that particular data, right? Here you have a data component, the second one is, so part of data component, what you try to do, whatever the normalized database design you require, you will be going to develop using some sort of ER model. It's a object based, object oriented. Then in that case, you will have certain number of objects. So that means you need to identify what is the objects, what are the entities, and how these entities are related to each other. Okay, so you need to identify those things. That is what exactly we do in case of conceptual design, right? So that is what need to be done part of any data components. Okay, and once you have designed this ER model, okay, the entity relationship models, right? So once you have designed that, now what you try to do, then you apply denormalization. Okay, so you apply denormalization means you exactly, you know, modify this conceptual normalized database into the database design. Okay, so whatever the ER model that you obtained, okay, or the conceptual design you got, now you try to convert that conceptual design model into some database design. Okay, so like in part of database design, what you do, how you do, so usually you will make certain tables, you know those things, right? So you will have certain tables, right? And then those tables will have certain attributes, right? And then you try to find some primary key, you try to find some secondary keys, or you try to find some candidate keys, super keys. Okay, so these sort of foreign key, and this is the way that you try to convert this particular in a conceptual design into a database design. Okay, that is also need to be mentioned out here. And then you will have a physical design. Once you got the database design, then you will have to have a physical design of your database, right? Where you will be choosing right storage technique through which data can be accessed efficiently, right? So part of your physical design, you will be choosing, right, what is the indexing that you really require, okay, to how you can efficiently access the data, okay, how you can efficiently store the data or update the data. So these sort of like um, you apply some sort of indexing so as to store the data. Okay, so these are to be decided part of any data component. Okay, now as I said you, so design of software consisting of designing the processing component and data component. So as I talked to you, so it is it consists of, so any design of software consists of designing processing component as well as data component, right? We talked about the processing component in the previous slide, and now we discussed about the data component part, right? These two components may be designed separately or they may merge into single design dimension when we use object oriented. As I said you before also, so let's say, in case of functional approach, so functional software design approach, where we talk about these components separately, whereas in case of object oriented, so we will have a single design. Because why you will have a single design? Because you see here object, here we talk in terms of objects, right? And now each and every object encapsulates so data as well as its methods, right? So that means everything is together you find here. That is the reason why, so you merge both the things, right? Data component and processing components together, this sort of design. Okay, now so part of any part of any design, so usually the deliverable that comes out from this particular phase is a system architecture. Okay, so when you talk about any system architecture, so usually, so whatever the complex system that we have, so that will be decomposed into some sort of subsystems. Okay, now this decomposition can be in terms of so decomposition can have different partitions, or the vertically we try to partition them, or we try to horizontally partition them, right? And now this horizontal partitioning is something called as a layers. Okay, and whereas vertically partitioning, that is what exactly the partitions we call. Now we can see, let's say an example, we will see that you will be able to understand. So before that you need to know, so usually, so each and every layer, as I said you, so if you're going through horizontal decomposition, there each layer and partition is given specific responsibility. Okay, so that means whole system is divided into certain layers and partitions. Okay, and each and every layer and partition has a specific responsibility. Okay, so now, so you need to define different modules. So they are as a basic building blocks. So now usually what happens, the various number of modules, you need to define each and every subsystem in terms of certain number of modules, and keeping together all of these modules to form a subsystem. Okay, and now each module has a specific function to perform. Okay, so that means each and every module has a specific function. Okay, And usually when you talking about any function, that means exactly it is a piece of code that will be, it's a piece of code, right? So that is what exactly implemented using some programming language, right? So now, so the several modules together that forms a subsystem. Now several subsystems that together forms a overall system. Now that is what I said you. So it is a system architecture, right? Or you can say software architecture. So here usually you will have some modules, right? And these modules will be interacting with each other. Okay. Now these interactions, their interactions done through passing some data values and also getting some results. Okay, that means you can think of something like this. Let's say one module, there is a module A, there is a module B. So module A is going to call to module B, and it can pass some data as well as, okay, and then it can get some data from the module as well. Okay. So now you can think of a simple example here. If you talk about any computer network protocol stack, okay, or any layered approach of solving network problem, right? So now we know that. So the whole computer network is divided into certain layers. So the layer starts with the presentation and it ends with a physical layer. Okay. So now you have a horizontal layers, right? And now each and every layer has a specific functionality. Now your presentation layer has a specific certain specific functionality. Okay. So specific actions will be carried out by this particular layer. Similarly, your physical layer is also going to perform certain activities, right? So now there is another example you can say in the right side. Now you can see, so here you can find the layered approach as well as vertical. Okay, so the whole system is divided into 3 layers, and the third layer, a second layer, that is again further partitioned into 2 subsystems, you can see. Okay, now let's say there is a data display and there is a there is a storage. Okay, there is a storage. Now in that particular storage you can think of something like this. So there is a text data can be stored as well as image data can be stored, right? Now you can think of something, there is a component called data display. So let's say it wants to display some text data, then what it is, what will be the path it will be taken. So the from the storage the text data will be taken and displayed. Okay, similarly if you want to get the image data, so from the storage you take the image data through this partition submodule, and then the data will be displayed. That means the data display module is talking to text data module. In turn, this text data module is talking to storage module, right? So similarly, the data display can be talking to image data module, and this image data module is talking to storage data. So this is the way that so the the software architecture or the system architecture can be developed. Okay. Now, so here part of any system architecture or the software architecture. So what it try to do, it try to maximize module independence. Okay, so that means each and every module should be independent. Okay, it should be independent. It should not be dependent on other modules, right? So that is what you try to maximize. That means that the independence you need to increase. Okay, and minimize what module interdependence. Okay, so and also we try to minimize their interdependence between modules. Okay, so the module itself should be very independent. Okay, and also it should not dependent on other modules. Right, so there are 2 such characteristics. One is called cohesion and the other one is called coupling. Okay, so the module should be I mean in this way you can say So this should be high cohesive. The module should be very high cohesive. Okay, and it should have low coupling. Okay, it should have low coupling. That means the module should not have interdependency. Uh, more I mean Modules should not interdependent on each other. Okay, so that should be reduced. Reduced. Okay, and module should be very independent, so it should not take any help from other module. Okay, it should carry its own activities. It should not take any help from other module. That is the way that you need to understand. Okay, so that means you need high cohesion and the module should be high cohesive, and the coupling should be very low. Okay, essential for maintenance. Why this is really required? So the reason is that if these modules are independent, okay, if they are very independent, let's say you find a defect in one of the module, then what will happen? Now this module can be replaced by a new module. Okay, that means it is not, if that module is not at all dependent on other modules, that means it is not going to affect the other modules. Okay, so yeah, so if you have if the modules do not have if the modules are very independent, then what will happen? So easily you can replace that particular module. Okay, whenever you find any defect, that means it is not going to affect the other modules. Okay, so that is the reason why. So this sort of you should always try to maximize the module independence and minimize the module interdependence. Okay, now this software architecture can be defined in terms of modules, and their interactions can be captured through a diagram notation tool called structured chart. Now this software architecture can be captured through a notation called diagrammatic notation called structure chart. Okay, so part of software architecture, what you have learned here. So usually software architecture can be defined in terms of modules. That means it will have a certain number of modules, and these modules are talking to each other. Okay, in order to achieve some in order to accomplish some high level task. Okay, so used in functional methodology to depict modules and their calling relations. So we'll talk about that. So it uses some sort of methodology to show that how these modules are calling to each other. Techniques are available to go from DFD to structure charts. So when you part of any analysis phase where we talked about data flow diagrams, that means how this data flowing from one processing to the other processing. Okay, that is what we have captured. Now here part of software architecture, we have seen what are the different modules that you have. Okay, so now, so if at all data flow diagram is developed, okay, and that DFD diagram can be converted into a structure chart, there are some techniques. Okay, so through which you will be, when we are talking about DFD, we will talk about this thing. Okay, so we will talk DFD later at later point of time, right? So now part of any structure chart, so usually it is a hierarchical structure. So you will have certain modules. Module at level I calls to module at level I plus 1, and control flow is not shown. So I'll give you an example here, then you will be able to understand. Let's say you have certain modules, right? So one module is here is a task. This is one is a task, and at level it follows some sort of a hierarchy. Okay, so it is a hierarchical structure. So now here you have a level 1. In the level 1 you have one module, and level 2 you have 3 different modules. One module here is get input. Okay, there is a other module here is a processing, and the other one is a produce result. That means it is going to display the result. And now this particular module is calling these all modules so as to accomplish a particular task. Okay, so now you can see here. So what is happening? Let's say so task 1, whenever you wanted to get some processings to be done. That means let's say there is a data item called X. Okay, so now when this task one need to get a data item, so it will call this get input module. Okay, so now this get input module, captures the data X, and this module sends this particular data to the task module. Okay, through module calling. So each and every calling is done through by passing some data, as I told you before also, right? They can send some data as well as some results, right? So this particular module is sending X. Now this X is again sent to the processing module, and the processing module processes this X, and in return it is giving Y again back to the task one. Okay, so now the task one wants to display whatever the data being processed. Okay, so now after getting this Y, and this Y will be sent to the produce results module. That means the produce results module will display the data Y. So that means it takes X, okay, and then does some processing. It gives Y as a result, and this result will be displayed. Okay, so this means you can think of now here. Okay, so there is a flow of data as well as certain number of modules, right? So that is what. And these lines connecting to each and every module, that means the modules are associated. This task one module is dependent on this particular module, and this module is also dependent on processing module, and it is dependent on this particular module. But now this produce result is not dependent on processing module here, directly, but indirectly it is also dependent. Okay, so you can think of modules on level 2 can be decomposed further. Now at level 2 also, you can, if the problem is very large, in that case again these modules can be divided into sub modules. Okay, so it all takes in a hierarchical structure, right? So modules at higher levels generally do coordination and control. Modules at lower levels do input output computations. So that is what exactly we have seen. So the lower modules, so they do input output and processing also, right? And the higher level modules, they exactly control, right? So this is the module exactly controlling all different modules, right? So now structure chart may show important data passing between modules and also show main iterations and decision making without much detail. Now, so in part of the structure chart, what you can see what is the data passing between modules. That means we have seen here, X is the data that is being passed between the task one module and get input module, right? This is what we can see. Also, so main iterations and decision making without much details, right? So it will also show, whether if a particular module calling a particular module several times. Okay, so that is what iterations. Okay, and also if at all any decision making is involved, let's say if this condition happens, then only the module should call to the other module. If this sort of decision making is there, so that is also need to be shown in the structure chart, right? So now this can be represented through this sort of diagram, right? So to a loop you can see here, right? So that means through this thing, that means module A is going to call the module C and D several times. Okay, module A calls C and D module repeatedly. However, the details of how often the iteration would be done are not given on the structure chart. That means in the part of structure chart, it will only show that, so the module A is going to call several times C and D, repeatedly, but how many number of times it is going to call, that will not be mentioned here. Okay, similarly also, so decision making can be represented through a diamond symbol. Okay, so now here, so that means it will show you that there is a decision making, but it will not say you what is the decision making here. Let's say in case of any program that you see, if x less than 10, then only it should execute certain number of statements, right? So now there is a condition mentioned, but here what will happen? It will say that there is a condition, but what is that condition will not be mentioned here. That means if certain conditions are met, then only A module should call C. If certain conditions are met, then only it should call D. These sort of things will be represented through any structure chart. Okay. Now there is a object oriented approach. So like function oriented. So where you talk about the classical method, okay, the traditional method, or the conventional method, where you do have different functions and these functions are going to call each other, right, by passing some data. So that is there. But now how you going to have the design when you are going through any object oriented approach, where you will have certain number of objects and each and every object is encapsulated with data as well as methods or the properties, right? So when you are going through any sort of design, object oriented design, usually you will find certain number of classes. Okay, you have some class, right? So a class consists of certain objects of similar type. Okay, now inside a class usually you have again the data and certain number of methods, because these data and the method, they are common for all of the instances of a particular class. Okay, so usually you have properties, you have behavior, that means methods. So you have a data attributes as well as methods and some sort of inheritance, like you these are the object oriented methodologies features, like inheritance. You have a inheritance, you will have a polymorphism, these sort of things, right? Data abstraction, so those sort of concepts, right? So data and executable functions associated with the class. So usually, as I explained you all already, so this is a paradigm that combines data and processing together on a single dimension and identifies class which have structural properties and behavioral methods defined for them. So usually within a class you will have data as well as processing, that means methods or the functions. So that is the reason why the paradigm should combines both things. Okay, whereas in case of a simple functional approach, where you see processing and data component, they can be designed separately. Okay, so class diagrams show static structure of a system. Interaction diagrams are used to capture dynamic behavior of classes and objects. Like there are UML diagrams. We'll talk about them, right? So, but when you talk about any class diagram, so they show the static structure of the system. That means whatever the classes, entities, so how these classes are connected to each other. So those things will be defined there, right? Whereas interaction diagrams are the ones through which we try to see different dynamic behavior of these classes and objects. Okay, how at our different point of time, how these objects behave to a particular input, right? Large system decomposed into packages. Sometimes you will have if you are talking about any large system, so that can be divided into certain packages, and the part of packages you will have certain number of classes, right? These sort of things that you can see always, right? So altogether what we are going to see here is a design document. So is similar to the previous phases. So part of analysis phase, we have seen software requirement specification document, right? And part of part of feasibility study. So you have feasibility study report, and part of problem definition. We have seen that there is a problem definition document. Similarly, here you have a design document. Okay, so a design document should have, these are all different subsections. So it should have a brief introduction to to what is that design we are going to do, right? I mean, what are the technical alternatives that you have, right? So what is the objective of it? So it should introduce that. And then problem specification include here the data flow diagram, entity relationship diagram, or class diagram. So you should specify the problem in terms of data flow diagrams, or you will have ER diagrams, as I said you before, and or you will have a class diagrams, because you're going to specify your data. So data specification can be done through these all things. Okay, so by using some data flow diagrams, we'll talk about data flow diagram, and you might have learned this entity relationship diagrams in your database, right? So, and you might have gone through class diagrams, right? So because here you will have a certain number of classes. And this part of design document format, you will have a structure chart. That is what exactly the one of the important deliverable from this design phase, right? So that is the software structure, gives the high level software structure chart, identifying major modules and major data elements in their interfaces. That means you can understand easily, as I already explained you. So here it will show you some structure chart. Okay, the structure chart should be explained here in part of software structure. And data definitions for major data structures, files, databases, if at all, so that those things will be discussed, defined here. Okay, their definitions should be given here. Okay, I mean module specifications, right? So because as I said you, so there are certain number of modules, right? Okay, and these modules are going to interact with each other, right? So that is the reason why. So here you need to specify each and every module. So you need to indicate what is the input, what is the outputs coming from each and every module, what is the purpose of that particular module, and what are the subordinate modules for each module, right? As I told you before, like at a level 1 you have a module, and for that particular level 1 module, so you have 3 different subordinate modules, right? So you need to talk about them also, right? And then you need to have a requirement tracing, right? So where it should so through this particular section you should be able to know that what are the requirements. Okay, what are the requirements? Okay, those are met through these modules. So let's say you have 10 requirements. Okay, so first 3 requirements can be developed through met through module A, and the next 3 may be through module B, and the rest of the 4 requirements can be met through module C. Let's say if that is the case, then so here you should talk about all those things, right? This module is going to meet this requirement. This module is going to meet this. That means you should be able to, at the end of the day, you should be able to know what are the requirements they are exactly addressed through which particular module. Okay. Now, design document format. So this document will be reviewed by the technical people, ensure that this document is comprehensive. So that means because this is the document exactly will be reviewed by all technical people, those who are going to implement this particular design. Okay, so after this design has been done, I mean, what is the you have designed the physical design of a database, let's say for example. So now the database designer have done this design, but now this will be implemented by a database programmer. Okay, so that is the reason why. So that means the document whatever created from here, that will be read by technical people actually. Okay, and so that is the reason why it should be very comprehensive. Okay, ensure that it covers all functions identified in the SRS documents. So part of this, as I said you, so it should all cover all the functionalities or the requirements that are defined in the SRS document, as I said you. So all of these modules are exactly going to meet all the requirements whatever there in the SRS. Okay, so that is what. And now you have a detailed design. So as I so part of any detailed design, we go very specific implementation alternatives already selected in previous step, giving overall software structure chart, right? So software architecture we have seen in the previous phase, where there are certain number of modules. Okay, so now what you try to do here is the part of detailed design, you provide specifications or the implementation details in such a way that detailed way you need to provide it in a very detailed way, so that these modules can be directly coded. That means for that module, so everything will be mentioned out here. So you will have to have this function, and this function should be developed using this this sort of programming language, or maybe you need to have a, whether you need to have here a database or you need to have a file structure. Okay, whether you are going to use a file structure to store the records, or you need to have a database. So every individual detail is mentioned out here. Okay, so now, so that uh, so ultimately, so here what will happen, each and every component is defined in such a way that that component can be directly developed by a programmer. Okay, so you will have so part of detailed design means you will have a piece of component. Okay, pieces of components, and each and every component is defined in such a way that that can be directly implemented by a programmer. That means what is the data structure you need to use, what is the algorithm that you need to use, what is the database you need to use, what is the programming language you need to use. So everything will be mentioned out here, part of detailed design. Only the programmer directly going into each and every component, and that will be converted into a piece of code. Okay, so that is the reason why, so each component is defined further for implementation. Now, so what would be the deliverables from this detailed design? So usually program specifications, so pseudocode, right? So every pseudocode is mentioned out here, part of any detailed design, as I told you. So everything is there, only that will be converted into a implementation. Okay, I mean converted into a code. Okay, so that is the reason why here the program specifications should be given. Okay, I mean, how you going to access the data or organize the data, right? What sort of data structure you need to use, whether you need to use a file structure or a data structure. Okay, so how you going to store and access the data? If at all any hardware involved here, so you will be providing specification for those hardware as well as. Okay, and so some of these test plans. Okay, so part of detailed design, you will also be giving some sort of test plans, and then implementation schedules. Okay, so how much time, within how much time you need to implement that particular module. Okay, and how you going to test that particular module. Okay, how you going to test that particular module, right? So that testing plans should also be mentioned out here. Okay, and in a technical review, right? So this particular usually phase ends with a technical review. That means after going through the detailed design is prepared, and this will be reviewed by the technical people who are involved in designing this particular document. So hereafter, so once you got the design and then you got the detailed design, now the phase here is implementation. Okay, so how you going to code it? Okay, once your design is ready, so the programs are coded, debugged, and documented. That means that it need to be implemented or it need to be coded using some programming language. If at all any bugs are there, so those bugs need to be corrected. Okay, I mean it need to be debugged, and then finally you need to document them. Okay, and initial creation of data files, their verification. So if at all, so manual existing data is converted to the data files and databases. So if at all any sort of data, if it is there, so that data need to be converted in terms of data files or the databases, and then you can you can apply that particular data. Individual modules as well as the whole system is tested. That means what you try to do, once those modules are coded, now individually you need to test those modules, and then after integrating all of these modules, and also you need to test once again. Okay, so those things will be done here. So you will have to test individual modules, and after integrating all of these modules, again you need to test them, right? So because finally as a whole the system is working fine or not. So that sort of validation need to be done. So part of implementation phase only. Okay. Operating procedures are designed. So if at all any how you going to operate this particular software, right? So that is also need to be mentioned or designed here. Okay, user does acceptance of the system, so user should agree to the system, right? So this has to be taken part of implementation phase only. This is carried out. I mean, the user should not it should not happen like this. The user is not going to accept the system. So if at all there, so those things will be resolved out here only. System is installed and switch over affected. Okay, so I mean ultimately, so you know the particular system whatever that is implemented, developed, and it should be installed there at the client side. Okay, now so operations and maintenance phase. So this is the last final phase where we talk about during this particular phase we see whether the system we installed so is exactly serving the user's need or not correctly, whether it is giving any whether it is not solving the user problem if at all there. So those sort of things will be recorded here, and then accordingly we need to maintain the software. I mean, we need to change the software if at all it has some error, so those errors need to be resolved here. Maybe sometimes so you try to enhance certain existing features, okay, or the functions, or sometimes you can add some new functions. Okay, so or sometimes you can try to port this particular software into a different environment. Let's say you today you developed a software, okay, and that software now you installed in the Windows 98. Okay, there is a Windows 98 version, but but because of the operating system versions are changed in the market, now the version is a Windows 10. So yeah, so you going to port that particular software into the Windows 10. So then when you port it to a new environment, what will happen? Certainly you require some maintenances because the drivers requirements or the kind of hardware support may not support. Yeah, so there are many sort of maintenance really required. Okay, and those things should be maintained. So usually when you talk about this particular phase, all of these phases, so the summary here is each phase has a well-defined task and a deliverable. That means each and every phase has a well-defined task. Okay, and also it gives you some output, a single output. So like SRS is the part of analysis phase. System design document is from the design phase. Okay, detailed design document from the detailed design phase. Testing report may be coming out from the testing phase. Okay, so likewise, so each and every phase has a deliverable, and feasibility establishes alternatives and carries out cost benefit analysis. So so your feasibility phase exactly, so it establishes what are the different alternatives, and then how these alternatives are cost benefit. How these alternatives are in terms of cost and benefit. Okay. Requirements analysis is very challenging. That is what we have seen. Okay, SRS, because you try to establish the requirements here. Okay, design step consists of architecture, database, interface design. Those things we have seen. Software architecture, we have seen database design. These are all part of design. So adherence to software lifecycle model helps to do various development activities in systematic and disciplined manner. This is what you learned in the very first beginning lecture. Also makes it easier to manage software development effort. Okay, so we stop here today. Any doubts so far, students?
No, sir.
Anyone has any doubt?
No, sir. No, sir.
No.
No, sir.
So it means that
sir.
I think you understood everything, whatever I explained throughout the lecture. Or you have not understood anything. What I should mean? If there is
So
no
we
question.
understand, but once we will revise, so we will understand easily.
Yes.
Okay. Okay, fine. So you revise, you go through my videos. I will upload these videos today in the Google Drive. Okay. So yesterday I uploaded the slides in the Matrix. You can find the slides. Okay. By today I will upload these videos. Okay. So you go through these videos. If at all you are going if you are getting any doubts again, so you can call me anytime. Okay. And you can have discussions. Okay, further on this. Okay.
Sir, are you available
Yes.
on WhatsApp?
Yes, I am available all the time through all modes. Okay. So
Okay, sir.
whenever you have any doubt, you can call me. Okay. You can message me. It's not a
Okay, sir.
problem. Okay.
Thank you, sir.